It's math with AUB. Let's deal some questions about conic section including straight line. Our question number 1 reads says focus of the parabola. We are asked to find focus of the parabola. Focus of the parabola. If the product of x and y is not present, then either x has a square or y has a square. This is the equation of parabola. Look at this question. There is no term involving the product of x and y, and only either y has a square or x. It is the equation of parabola. Parabola. Some elements of the parabola on inspection we can easily manage. We can easily conclude that what is. If no product of x and y is present, no product in x and y is present, then either x has a square or y has a square. It represents a straight line. It represents it represents the parabola. It represents the parabola. If the product of x and y is not present, either x has a square or y, it is the equation of parabola. Then, keeping this thing in mind, eccentricity of parabola is always one that is denoted by small letter e. Eccentricity is 1. And we can also predict about length of lattice rectum. Length of lattice rectum to be y has a square, then whatever is the coefficient of x, its modulus is our length of lattice rectum. Minus 4 means length of lattice rectum is 4 in that case. Length of lattice rectum is 4 in that case. If no product of x and y is present, then either x has a square or y has a square. It is easy to classify. This is the equation of parabola. So does in our case y has a square and no product of xy. It is parabola. Parabola. Some elements of parabola can be predicted, guessed, surmised directly. Eccentricity of parabola is always 1, and length of lattice rectum. When square is in y, square term is present in y, then the coefficient of x term is our length of lattice rectum, and there is a negative sign we have to discard because length never be negative. That's why we have taken positive 4r mod of the coefficient of the x. If y has a square, then the coefficient of x is our length of lattice rectum. If x has a square, then the coefficient of y is our length of lattice rectum, provided that we have to discard the negative symbol. Then vertex, focus and directrix, the remaining 3 elements are interconnected. Vertex, focus, directrix, they are interconnected. Square in y, then we have to transform this equation in that form. X minus h whole square is equal to 4 times y minus k. If square is in x, in our case y has a square, we have to convert in that y minus k whole square is equal to 4 times the x minus h. These are the standard equations of parabola when vertex is not at origin. When vertex is not at origin, in our case y has a square, so writing the y terms on the left hand side, shifting the rest on the right, it will become 4x plus 4. Make it perfect square, y square, 4 can be written as 2 times y times 2 is equal to 4x plus 4. To make it perfect square, we can easily predict that our second term is 2. Second term is 2, y square minus 2 times y times 2. Then by adding 2 times y times 2, by adding 2 square on both sides to get perfect square of the term including y, we have 4 plus 2 square. Adding this quantity on both sides, now it is a perfect square quantity of y minus 2 raised square, and here 4x plus 4 plus 4, y minus 2 raised square is equal to 4x plus 8. Or transforming the given equation in that general form, taking 4 common from here, we have y minus 2 whole square is equal to 4 common, we have x plus 2. Now vertex is, solving for x, it will become minus 2, and here y is 2. That's our vertex. We are asked to find focus. Then to find focus, we have vertex. Add a into the vertex, we get focus. Vertex plus a. What is a? How to hunt down a? That is, if y has a square, whatever is the coefficient of x minus h, it's equal to 4a. In that case 4a is equal to 4. We have 4a is equal to 4. It gives a is equal to 1. Our vertex is minus 2 comma 2, adding 1. A question arises whether we have to add this in abscissa as well as in ordinate or in either one. Let's see. Square in y, we have to add in x. Square in y, we have to add in x. Minus 2 plus 1 comma 2. We have minus 1 comma 2. We have minus 1 comma 2. So focus in that case is minus 1 comma 2. We can easily find the directrix as well. Let me manage some space for myself. Directrix, that is mine, vertex plus a is equal to focus. I write in words, and directrix is given by vertex minus a. Vertex minus a is equal to directrix. Directrix is denoted by L. We have vertex, that's minus 2, 2, and the value of a is 1. Same question. Square in y, we have to add subtract in x. It will become minus 2 minus 1 comma 2. That is our directrix. So it is minus 3 comma 2. Writing in equation form, this is our directrix. X is equal to minus 3, or one can write x plus 3 is equal to 0 is our directrix. These are the elements of parabola. A centricity always equal to 1. If no product of x, y is present, then we can easily predict either y has a square or x, it's equation of parabola. Square in y, whatever is the coefficient of x, it's our length of lattice rectum, provided that if negative symbol is present, we have to discard because length is always positive. Then transform either in this form, in this, as according to square in x or y. In our case, y has a square, we have managed in that form by completing square. Whatever is present here, that's the value of 4a. We have compared and we have find out the value of a. Vertex plus a is equal to focus. Square in y, we have to add subtract in x. We have to add in x abscissa to get focus. Similarly, vertex minus a is equal to L. Square in y, we have to subtract in x. Minus 2 minus 1. As directrix is a line, converting this point into a line because x is equal to minus 3. This extend. This represents our vertical line. Vertical line at x is equal to minus 3. That is our equation of directrix for that parabola. Moving towards the next question, we have